Hello. So yeah, my name is Floris. I've been a Python developer for a while, and I've been for like last year and a bit. I've been working at Kobe.io, which is a monitoring system, and the whole backend we kind of built using the sort of the ideas behind that I kind of explained in this talk. And I think it's a very nice way of building the backend infrastructure. Obviously, like, you know, as any code, you know, we make mistakes, we didn't always follow the right thing, so this is something that we also learned. Yeah, and I think it's a really good way to build your backend infrastructure, so it's kind of why I'm trying to talk about this. As I said, it's like, I'm trying to cram quite a lot in, maybe this is like 2 talks, but I'll try and go fast enough through it. So I'll kind of split it up in 2 parts. Like, firstly, I'll try and talk about the, I think how we got to sort of microservices and why message passing is kind of a nice way of architecting your larger systems that way. And then in the second part, I will talk a bit more about ZeroMQ, about why ZeroMQ is a nice transport layer to do this communication between your services. And then I'll give some tips about ZeroMQ. ZeroMQ is very good documentation, but yeah, just, you know, not the rough edges, but sort of the what I would find helpful to sort of know some starting to use it very much. And then I'll talk a bit about how some common patterns we see in our microservices, and sort of what we're using there. Because I have to, I'm not going to do that much introduction, so I'll kind of assume that you sort of vaguely know ZeroMQ is like a socket library. It's not, it doesn't have a message broker, a central broker or anything. So it's a socket library essentially is how I describe it. So I assume you sort of know those basics, and likewise I'll assume that you sort of know how HTTP works, and etc. Okay, so message passing is kind of if you think about, you know, if you have cooperating processes or something, or you know, multiple tasks that need to cooperate, message passing is really the natural way we work. I mean, I'm talking to you now, and I'm not sort of we're not operating from shared memory or anything like that. In processes that would be you know, some shared database or shared memory or whatever. So passing messages is really like a good and proven way of how this works very well. And it doesn't always have to be like completely synchronous. So right now I'm talking to you, but you know, you're not talking back to me until question time or something like that. So it's a very nice way, and it's also a very nice way in designing your programs in a way. These 3 people, back in the late 70s, they were asked to write some software for something, and as any good software developer, they decided to first write a language. But the insight they sort of came to meet the requirements that they were aiming for was sort of like if they just kept breaking down the programs, the problem they were trying to solve, into ever and smaller entities, smaller tasks, and instead like work with and pass messages between those, and they ended up being able to build very robust, scalable systems using they wrote Erlang. This is sort of, and your little processes or tasks kind of just if you keep simplifying them enough and keep distributing the work, they end up kind of very, very simple loops, and they just like receive a message, do some work, and send some messages off. And it's a very, they were able to build very robust and reliable systems. It's also usually called active systems. And some key things about that they developed in their languages that kind of are relevant to us still is well, Erlang is obviously still a relevant language on its own right as well. But is that they had like this philosophy of don't really try and do error handling. If your process has an error or an exception or something, just let it die, and it's someone else's responsibility sort of log that and restart your process. And then they built like these supervision trees these supervision trees to monitor all those different processes and restart them when required and make sure that they can all keep operating in the face of errors. And these days, and I think this is sort of the pre-evolution to microservices, because these days we have this sort of this flexibility of like the infrastructure around us has kept improving. You know, we started getting containers and we started getting cluster managers like Kubernetes, which is I think is a very good system to manage it. And it means because the infrastructure has been improving, we have been able to shrink our application. So we're going away from this monolithic thing, and we can shrink it, and we can start going not quite, you know, that as extreme, but we can start going towards this sort of architecture of building resilient systems. And we have like just our cluster manager, Kubernetes can monitor our containers and schedules them and make sure that they can scale up and down as we need. If they crash, they get restarted, etc. So we can sort of go towards that. We can go towards the architecture, and we can benefit from this design. But obviously, to do that, we need to and if you really think about if you designing on that level your overall application, like thinking of message passing design, I think is very very useful, rather than thinking of what you have in the monolith. You have function calls, which is very much like, you know, you have a request reply thing. But if you design it with more of generic message passing in mind, I think you get more benefits. So that's sort of very quickly like where I think the sort of what comes from, and what I keep in mind for like thinking about the overall application design. So ZeroMQ itself, as I said, it's a socket library, really, is how I describe it. So it takes care of all the nasty networking details, because networking has a lot of nasty details, and basically packages it up so that you basically have a reliable sequence of messages that you can send from one process to another. So you send it between your sockets. And you do not have a central broker or anything. So you do send messages basically from peer to peer. And it allows you, and it has different communication patterns, which you probably might have heard of already. And it allows you to build many more kind of communication patterns than things like plain HTTP. So HTTP is kind of the reason I sort of, I mean, HTTP has its use, obviously. It's a very good protocol, it serves very well, and everything has its application. But the reason I sort of say like, is that HTTP is very strict to request response, and that builds you kind of, that encourages you in a way to build very tightly coupled systems. And this idea that you know, if you do it, you always have to do this request to response cycle. You always have to set up the TCP connections and things like that underneath it. And you can do things like, you know, fire off a bunch of requests with async IO or something, and then wait for replies, and you can add timeouts and all sorts of things, or use thread pools if you don't like async IO. But you still have this, you still end up the messaging pattern between your different services still very much based on this request response. And also, if you end up doing like a call to one, if you end up doing a call to one of your services, and that service calls other services, etc., which is sort of the architecture, you basically end up with this. You basically end up having function calls like you do in your monolith. And at that point, you know, you just have function calls, but you also have a network, and networks fail, so you just introduce more ways of failing in a way. That's not to say that, you know, you can't build good systems with HTTP, but that's sort of where I contrast this to. So ZeroMQ itself is a very, the nice things about it is a very low overhead kind of messaging layer. So it does like the horrible stuff of keeping persistent connections, making sure that you have low latencies and etc., but still have high throughputs and all that sort of thing. It gives you this reliable ordered messages that you get between it, and it has various messaging patterns that I said, and it also it's got a very asynchronous it's got an asynchronous user API, which means like that probably doesn't mean what you think straight away. It basically means that the user API is very, very normal. So you send a message, you send, say, so you call send with a message. And from the user point of view, that is just an atomic operation that happens straight away. And it just goes into the library, and the library then keeps track of, the kernel buffers being full and having to pass that message reliably across to the other side and all that sort of stuff. And on the receive side, it's also very, very, it's an atomic call, you receive a message and you just get the whole message. So that's kind of a very nice thing. So part of that means that it transparently reconnects. So if the other side isn't there, it doesn't really matter. So you can start up your client before your server because they just try and reconnect, and the message just goes on a queue and waits until the server is there, sort of thing. On the other hand, ZeroMQ, it's not a silver bullet either. One of the downsides of going this route is that it is lower level, so it's a socket library. HTTP provides more on that because it already does a protocol. The downside with ZeroMQ is that you will be kind of constantly designing your own protocols in a way between your services. That's not a bad thing, but in general, like the two main tips with protocol design between your services is one, keep it simple, obviously, and two, always use versions. So just make it very small, very strict, and always put a version frame at the beginning of your message, so that you can upgrade your services and you can constantly change your protocols as you need to change. The other main downside in our experience is kind of that, as I said, it transparently reconnects, which means that you do not really know if a peer is connected. And this can be annoying to work with if you really do need to know that. You can sort of try and write your protocol so you don't have to worry about it. If you do really need to know if a peer is connected, then you have to go and do something with hard beating, etc. But that's kind of a bit complicated. So queues, you have queues. Like the main thing. So now I'll kind of move on to like some quick tips about what I think is kind of important to keep in mind when you're starting to experiment with ZeroMQ. So queues give you an important thing about queues is to know when they get created. Because ZeroMQ doesn't have a broker, this queue is actually attached to your socket. So you send your client socket and your server socket both will have a queue. And when you send a message, the message will go on the client socket, and then it will go over the line, and then it will go into the server socket until someone reads it. And it's really kind of important to know when the queues get created and when they get destroyed. And they don't tend to make that terribly obvious in the documentation. And the main thing to keep in mind is sort of if you have a client socket, the queue gets created when you say connect to the server. Now remember, the server could not be there, so the queue gets created, you can start putting messages on it. And then at some point the connection will happen and messages will start flowing out of your queue to the other side. On the other side, the queue gets created when the connection actually happens. And then and then it will remain there until the peer disappears. And this is important so that you know if one of your services dies, you know where the message in which queue it could have been, because that queue is going to be lost. Depending on the reliability requirements of your service or of your protocol, that's something to keep in mind. The second important thing queues do is they give you back pressure. So if they're full, they can, depending on the socket type, they will block or they will start dropping messages. The thing to watch out for when you blocking it's a very nice way of giving back pressure, but because ZeroMQ is actually a C library, it blocks in C code, and that to you as a Python developer, that means you just have it's somewhere stuck in the C stack and you don't really have any visibility. So in the Python bindings, you can configure it to raise an exception instead. It means you can write a log message saying my queue is full, I'm going to block, and at least you know what's going on, and then you can decide to handle that how you want. Whenever you read tutorials about ZeroMQ, they always start with request reply. Request reply is a socket type, but it's not a very good socket type. They're actually they're talking about replacing it as well. So basically, I haven't got much time, so I'll skip through it. But skip request reply sockets. They're very difficult to work with, or they have their problems. Instead, deal router is kind of the two sockets you want to use. They're the workhorse, and the main thing to keep in mind here, again, I'll try and go quickly, is that the difference is that the router can address an individual peer. The downside of being able to address an individual peer is that it needs to know the identity of that peer. and in order to know the identity of that peer, it needs to have received the message first. So we can't create an outgoing connection. That's the main thing to keep in mind between root and dealer. Just think like, you can happily connect two dealer sockets together, that's fine. And also the thing to keep in mind is if you just connect to only one peer, then you obviously know where it's going to go, despite the fact that dealer distributes it over all its connections. The other main socket type you care about is pub/sub. So publish subscribes, I mean, that's what it is. You send direct messages one direction. It's a very good socket type. Thing to watch out therefore when you design a protocol is that it's a fire hose. So if a client can't keep up, messages will get dropped. No one will know. So in your protocol design, if you do care about this, you want to put in a frame with a counter or something. So you just put some counter in, and that means the client can say, "Oh, my counter skipped some numbers," and then it knows that it missed some messages, and then it can, it's up to the client to go and try to figure it out. So service patterns is sort of going back to like your microservices. This is sort of what we how we found like recurring in our microservices. So a resource manager is sort of one thing I call. In general, so if you have a certain resource that needs to be managed, and your service just takes care of that. So generally, you're looking at root to dealer sockets in this case. And then the nice thing, well, the thing you want to do with this sort of thing is think of it as a state machine. Like your resource can be in different states, and if you actually write down the states, then you start with it having a nice overview of what happens, and then you write down your state transitions that can happen. And only then you start thinking about what your protocol would look like, how you want to send messages to that service to control the state of that resource. And the key thing to keep in mind is to think of there is that you don't really, it depends. It's kind of usually better to design protocols so you send a message saying, get me this resource to this state, instead of saying, oh, can you make this state transition? It means that you can do things like, you might not care about the response, you might just say, get me to this state, and you don't get a response message. And that makes you, if you get a large number of services working together, that makes it more resilient, because you get asynchronous messaging in return. Obviously, if you have to request a state, then you're going to have to get a response, so you're going to have to wait for responses in that case. But yeah, they sort of, think of, say what state you want something in. It's kind of a nice pattern to do in your protocol design. The other thing is like, consumers, obviously, this is publish subscribe. If you can use that at all, always use publish subscribe. It really decouples your services from each other, because no one is going to be blocked by anyone else. It's very nice. Whenever you can, go to that. It really avoids this sort of dead star architecture that I've tried to put in the background a little bit. There's some classical pictures for like crazy architectures that have most of it off slide, unfortunately, but the cool ones are on the sides. But never mind. Yeah, and it really simplifies, and it makes your overall structure more robust if you can use that. And then lastly, like this message stream thing is kind of, so as I said, like the infrastructure around you is kind of improving. So and what you want, this is something that we found quite useful. It's an internal kind of tool that we created. The key thing is like you don't have to really understand the code. The key thing there is that it was a pattern that because every service just became this sort of open a couple of sockets, put them into a poller, etc. And when there is something available, you read messages from it, etc. And the key thing that we just did that everywhere. And the key thing there is that we wrap that into an iterator, and you can just have a for loop, and the for loop, the iterator just gives you a message at a time, and then you just process your message. You sort of do whatever you need to do. You send it to other services and all sorts of things. But this sort of this approach of wrapping that into an iterator has been we find quite useful. This is actually public. Should probably split that off if you're interested in it. But yeah, it's kind of our own internal kind of boilerplate, and it includes nice shutdown, etc. So that's kind of managed to go through it quite quickly. I hope you managed to keep up. So this is sort of the summary of like when you're thinking of your large design between all your different microservices. Try and think not in a remote procedure call kind of way. Try and think in a way of passing messages, and you will be able to kind of have a more robust design really. And secondly, you may not like ZeroMQ. That's fair enough. It has its downsides too, but yeah, basically think past HTTP. There's more out in the world as well. So yeah, thank you for listening.
Okay, well, thank you very much for that. We have about 4 minutes, so we've definitely got time for a couple of questions if they're nice and brief and keep it friendly. And if you put your hands up, I see one over there. Okay.
The quote you had at the beginning referenced how REST couples systems together into a monolith. And one of the patterns that you mentioned towards the end of your talk was thinking in terms of the resource manager, which struck me as a resource manager, whether done over, say, HTTP or whether done over RPC, would imply some kind of REST elements of design. Could you maybe speak a bit more to that? And was that how do you see the distinction between, say, REST with HTTP versus resource management with RPC?
Yeah.
Sorry, with ZeroMQ.
Mm-hmm. Yeah, okay. So that's definitely an area where there's not as much benefit because, as you say, if you need a response, and it's kind of where I was alluding to. If you can design your protocol, so because I said like try and design your protocol, so you say go to the state, and in that case there are certain operations where you don't have to worry about the response. So your application can just send a bunch of messages to the resource managers or the front end, whatever it kind of needs to do, and then assume that things are going to happen. If it doesn't need a really strong confirmation of the right things have happened. So, but it's definitely that area. Sure, HTTP, there's no real downside. Certainly, if you need to get the status of a resource, you have to express it once. HTTP doesn't really cost you that much. Yeah, there's nothing wrong with it. Really.
Hi, so you talked about maybe implementing counters to replay messages, or if you need to. You mentioned something about the dangers of losing messages. Is that so? Presumably, that is something you need to implement yourself. And what do you think is the overhead of that?
Yeah. So the specific case I mentioned was that when you do publish subscribe, you can, if you put a counter in, you can detect when you've lost messages. The downside, ZeroMQ comes with some guarantees, but as I said, like, if your messages are in a queue at a certain place and that process crashes, you do lose it. So you have to take this into account, and that's why you have to think about it as well. And ZeroMQ doesn't help. That's why I said it's lower level. So you have to deal with those sort of things. And if you need stronger guarantees, basically, generally people go into having some sort of broker. The ZeroMQ project itself has a broker that it's still kind of early days, I think, but that they call Malamut, I think, that tries to give stronger guarantees about messages if you do need that. If you do need stronger guarantees, sometimes I have nothing against Festival for the job. Sometimes Celery with RabbitMQ gives you stronger guarantees. That's fine.
Okay, I think we might have just enough time for one more. I've seen the hands just over there.
One thing I'm always wondering when I use ZeroMQ, is it possible to add some monitoring to it? Like with RabbitMQ, you could monitor the size of the queue, which you don't really seem to be able to do with ZeroMQ.
Yeah, that's right. So the queues are sort of a black box for you. You don't really know how many messages are in a queue. You don't really know when a message enters a queue and it leaves the queue. And the thing is, this feels counterintuitive the first time. and sometimes you're like, yeah, but I really would like to know. And I think there are some ways you can kind of track messages and then they sort of disappear. But you don't really want to go there because essentially, like the way the ZeroMQ project describes it is they think of the queues actually as an extension of the network because you've got messages along the wire as well, and you don't know where they are. They might be in a kernel buffer, they might be along the wire, they might be in a buffer of a router along the way. And if you start thinking, yeah, and if you think of it as an extension of that, it doesn't really matter. Either your queue is full or it's not full. And in there, I appreciate sometimes it's a kind of slightly unsatisfactory answer, but yeah, it's definitely one of the less nice, sometimes less nice things. Sure.
Okay, well, thank you very much.